Welcome to Tenor Tech, where I solve the problems you didn't even know you had.
You start by checking the module and card so nothing fails later. First, confirm the module voltage and power your microcontroller accordingly. Mismatched voltage can fry components. Next, connect MOSI, MISO, SCK, and CS pins to the MCU SPI pins and tie grounds together. Short wires reduce noise. Once done, insert a FAT32 formatted micro SD card with the adapter Write Protect switch off. Now power the board briefly to confirm the card is detected electrically before moving to code. You now handle the software handshake so data flows reliably. Initialize SPI with the clock speed your module supports and set mode and bit order. This ensures correct signal timing. Then mount the FAT file system using a robust library like SD-FAT or the SD library so you can abstract low-level sectors. Once mounted, open a small test file, write a predictable string, flush and close, then reopen for readback to confirm integrity. If reads fail, slow the SPI clock and retry to reduce timing errors. You finish by making the SD card use reliable in real conditions. Use buffered writes and call flush or close regularly to avoid corrupted files. This is why interruptions cause data loss. Make sure your application gracefully closes files and unmounts the file system before power down, and implement detection for card removal so you can stop I/O. If things go wrong, the common fixes are simple. Verify wiring and grounds, reduce SPI clock speed, and swap in a known good card to isolate hardware from software issues.
Thanks for watching. Subscribe to keep your life in tune.